everyone, today we're going to talk about prime factorization, and that's finding the factors of a number where all the factors are going to be prime. So if you remember, a prime number is a whole number with only two factors, 1 and itself. And I've put up this great chart here where all the prime numbers are green, just in case we need to reference it later. So I'm just going to move it over to the side and get it out of our way. And then I'm going to talk about two different ways we can find the prime factors of a number. The first way is called the tree way. So if I take a number like 24, I'm going to draw two little branches, and the first thing I'm going to ask myself is, what are two numbers that multiply together to get 24? Now there's lots of correct answers here. You can put any of them in except 1 times 24 because we won't get anywhere. But we can put in 2 times 12 or 3 times 8, 4 times 6. It really doesn't matter. We'll get the same prime factors in the end. So pick the first one you think of. So I'm going to put 3 times 8. Now here's the important part. We're going to ask ourselves, are these prime numbers? So let's take a look at the first one, 3. Is that prime? Look at our chart here. Yes, it is. So I'm going to go ahead and circle that. And we can ask ourselves, is 8 prime? No, it's not. So I'm going to go ahead and ask myself, what can I multiply together to get 8? 2 times 4 is 8. Is 2 prime? And yes, 2 is prime. The only factors are 1 and 2. So I'm going to go ahead and give that a circle. And is 4 prime? No, it's not. So I'm going to make myself some more branches. And how can I make 4? I could go 2 times 2. 2 is prime, so we're going to circle those. And then we think is a completed tree. Now to check our tree, we can always start at the top at the 24 and go down each branch and just make sure they end in a circle. So we have that branch ends there on the left, and then on the right, each of these ends in a circle, so we know we're done. There's no numbers hanging out waiting for us to come back. So we typically put these from smallest to biggest. So I'm going to go ahead and write the numbers out. It looks like I have 3 2s and a 3. And in between these, it's multiplication. So we have 2 times 2 times 2 times 3. Those are the prime factors that multiply together to get 24. I could also write this in exponential form. I could go ahead and say there are 3 2s. So I could go 2 to the power of 3 times 3. So that's the first way, the tree method. The other method also works really well. It's called the ladder method. So we're going to take that same number just to compare it, 24. And the difference here is that all the factors I'm looking for that multiply together have to have a prime number in them. So I'm going to go ahead and pull the prime numbers out just as I go to make it easier. So I always like to start with the smallest prime number, which is 2. And I ask myself, can I divide 24 by 2? And it's even, so I can. So I've already drawn my little step there. So I'm going to go ahead and put 2 next to the 24. 24 divided by 2 is 12. 12 is not prime, so I'm going to draw a step around it. Then I ask myself, can I divide 12 by 2? And I can, so I put a 2 on the outside. 12 divided by 2 is 6. Same thing, 6 is not prime. So I draw a little step around it. 6 divided by 2 is 3. Is 3 prime? Yes, 3 is prime. So that's it. That one's finished. So a little different. Our prime numbers are not in circles, but they're on the outside here of our ladder or our steps. And you can see them here. We have 2, 2, 2, and 3, which is the same as the 2, 2, 2, and 3 we got from the tree method. So I'm going to write them out here. 2 times 2 times 2 times 3, or the same exponential form. And that is how you find the prime factors of a number.